Good morning! Today, we will learn how to solve equations transformable to quadratic equations, including rational algebraic equations. There are equations that are transformable to quadratic equations. These equations may be given in different forms. Hence, the procedure in transforming these equations to quadratic equations may also be different. Once the equations are transformed into quadratic equations, then they can be solved using the techniques learned in previous lessons, like extracting square root, factoring, completing the square, and using the quadratic formula. Okay, let's have an example. Solve the equation x times quantity x minus 5 is equal to 36. So the given equation is a quadratic equation that is not written in standard form. So in order for us to solve it, we must first express it in standard form. So using distributive property, we have x squared negative 5x is equal to 36. Now, let us apply addition property of equality to make the right side of the equation 0. X squared minus 5x. So, in order to make the right side of the equation 0, we add negative 36. We also add negative 36 on the left side. So, the right side of the equation now becomes 0, and the left side is x squared minus 5x minus 36 is equal to 0. So this is now our quadratic equation in standard form. We can now solve the given quadratic equation using the method of our choice. So let's say you chose to use factoring. So what are the factors of 36? Or factors of negative 36 that will give us negative 5 when added or subtracted? That would be negative 9 and positive 4. Negative 9 times positive 4 is negative 36. Negative 9 plus positive 4 is negative 5. Now let us solve for the values of x. X minus 9 using zero product property. So we have x minus 9 is equal to 0 and x plus 4 is equal to 0. Solve for x. X sub 1 is equal to 9. X sub 2 is equal to negative 4. Therefore, the solutions of the given equation are positive 9 and negative 4. Another example. Solve the equation quantity x plus 2 raised to the second power is equal to 16. So what we're going to do to transform the equation in standard form is to expand the left side of the equation. This is the same as x plus 2 times x plus 2 is equal to 16. Now using FOIL method, let's multiply x times x squared. X times 2 is positive 2x. 2 times x, positive 2x. 2 times 2 is positive 4, is equal to 16. Combining like terms, we have x squared plus 4x plus 4 is equal to 16. Apply addition property of equality to make the right side of the equation 0. So we add negative 16 on the right side, so as on the left side of the equation. So the right side now becomes 0, and for the left side we have x squared plus 4x plus 4 minus 16. Combine the constant terms, so we have positive 4 and negative 16 is negative 12. Now solve the given equation since it is already expressed in standard form. Let's say you chose factoring. So you're going to have x. What are the factors of negative 12? That will give us positive 4 when added or subtracted. That will be positive 6 and negative 2. Okay, let's continue here. Apply zero product property. So we have x plus 6 is equal to 0 and x minus 2 is equal to 0. So for x, we have x sub 1 is equal to negative 6 and x sub 2 is equal to positive 2. Therefore, the solutions of the given equation are negative 6 and positive 2. Another example, we have solved the equation quantity x plus 5 raised to the second power plus quantity x minus 2 raised to the second power is equal to 37. So we must first transform this equation in standard form by expanding. So we have x plus 5 times x plus 5 plus x minus 2 times x minus 2 is equal to 37. Using FOIL method, we have x times x squared, plus x times 5, 5x, 5 times x, 5x, 5 times 5, 25. Plus, we have x times x squared, x times negative 2, negative 2x. Negative 2 times x, negative 2x. And then negative 2 times negative 2 is positive 4. Is equal to 37. Let us combine like terms. X squared plus x squared is 2x squared. 5x plus 5x plus negative 2x plus negative 2x, that will give us 5 plus 5, 10 minus 4, that is 6x. And then combine the constant terms, 25 and 4, that will give us positive 29 is equal to 37. So in order to make the right side of the equation 0, we will apply addition property of equality. So we will add negative 37 on the right side and on the left side of the equation. So this now will become 0. And on the left side, we have 2x squared plus 6x positive 29 plus negative 37 is equal to negative 8. The equation now is written in standard form. So before we can solve, we can still reduce the given equation. Divide the entire equation by 2. So in order to reduce it, 2x squared divided by 2, that is x squared. 6x divided by 2, that will give us positive 3x. Negative 8 divided by 2 is negative 4 is equal to 0. Now we can solve the given equation using the method of our choice. Let's say we choose factoring. So we're going to have x plus minus. So what 2 factors of 4 will give us a positive 3 when added or subtracted? That would be positive 4 and negative 1. Apply zero product property. X plus 4 is equal to 0. X minus 1 is equal to 0. Solve for x. So x sub 1 is equal to negative 4. X sub 2 is equal to positive 1. So the roots or solutions of the given equation are negative 4 and positive 1. Let's have another example. Solve the equation 6 over x plus x minus 3 all over 4 is equal to 2. Now this is an example of a rational algebraic equation which can be transformed into a quadratic equation. So how do we transform it into a quadratic equation? So we simply follow the steps written on the upper right corner of our slide. So for step 1, multiply the entire equation by the least common multiple or LCM of all the denominators. So what is the LCM in the given denominators? The LCM of x and 4 is simply 4x. So we multiply the entire equation by 4x. By distributive property, we have 4x times 6 over x plus 4x times x minus 3 all over 4 is equal to 4x times 2. Now look for possible cancellation. So here we cancel x. So we only have 4 times 6 and that is equal to 24. Here we cancel 4 and what will be left will be x times quantity x minus 3 is equal to 4x times 2. We have 8x. We have 24 plus, by distributive property, x times x squared, x times negative 3, negative 3x is equal to 8x. Now applying addition property of equality, we add negative 8x to both sides of the equation. 24 plus x squared minus 3x plus negative 8x. So the right side of the equation now becomes 0. For the left side of the equation, we have x squared. Negative 3x plus negative 8x is negative 11x plus 24. So the rational algebraic equation now has been transformed into a quadratic equation written in standard form. So we can now solve it using the method of our choice. X squared minus 11x plus 24 is equal to 0. So we choose factoring. We have x and x. So what are the factors of 24 that will give us negative 11 when added or subtracted? That would be negative 8 and negative 3. Now applying zero product property, we have x minus 8 is equal to 0 and x minus 3 is equal to 0. Solve for x. X sub 1 is equal to 8. X sub 2 is equal to 3. Therefore, the solutions of the given equation are 8 and 3. Let's have another one. Solve the equation 2 over x squared plus 1 over x is equal to 3. So step 1, multiply the entire equation by the least common multiple or LCM of all the denominators, and then step 2, simplify the results. So in the given equation, what is the LCM of the denominators? The LCM of x squared and x is x squared. We multiply the entire equation by x squared. By distributive property, we have x squared times 2 over x squared plus x squared times 1 over x. And then x squared times 3. Now what we're going to do is we will look for possible cancellations. So x squared in the numerator and denominator will be cancelled. So 2 will be left plus here 1x in the numerator and 1 in the denominator will be cancelled. X times 1 will be x is equal to x squared times 3 is equal to 3x squared. Apply addition property of equality. We add negative 3x squared on both sides of the equation plus negative 3x squared. The right side of the equation now becomes 0. And for the left side, we have 2 plus x minus 3x squared. So rearrange the terms in order to express it in standard form. So we have negative 3x squared plus x plus 2 is equal to 0. The rational algebraic equation has now been transformed into a quadratic equation in standard form. We can now solve it using the method of our choice. Let's say we choose to use the quadratic formula to solve the given equation. The quadratic formula is given by negative b plus minus the square root of b squared minus 4ac all over 2a. Negative, in the given equation, let us first identify the values of a, b, and c. So a is equal to negative 3, b is equal to 1, and c is equal to 2. Let us now substitute these values in our quadratic formula. So we have negative 1 plus minus the square root of 1 squared minus 4 times the value of a, which is negative 3, times the value of c, which is 2, all over 2 times the value of a, which is negative 3. Simplify, we have negative 1 plus minus the square root of 1 squared is equal to 1. Negative 4 times negative 3 is positive 12, times 2 is positive 24. All over 2 times negative 3 is negative 6. We now have negative 1 plus minus the square root of 1 plus 24 is 25 all over negative 6. What happens now is we have negative 1 plus minus the square root of 25 is 5 all over negative 6. So for our solutions, for x sub 1, we have negative 1 plus 5 all over negative 6. For our x sub 2, we have negative 1 minus 5 all over negative 6. X sub 1, we have negative 1 plus 5 is 4 over negative 6. We can still simplify it in its lowest form, and that is negative 2/3. So x sub 1 is equal to negative 2/3. X sub 2, we have negative 1 minus 5 is negative 6. All over negative 6, that will give us positive 1. Therefore, the solutions of the given equation are negative 2/3 and positive 1. Let's have another example. Solve the equation x plus 8 over x minus 2 is equal to 1 plus 4x over x minus 2. So step 1, multiply the entire equation by the LCM of the denominators. So what is the LCM of the given denominators? It is simply x minus 2. We multiply the entire equation by the LCM of the denominators, which is x minus 2. Using distributive property, we have x minus 2 times x plus x minus 2 times 8 over x minus 2 is equal to x minus 2 times 1 is x minus 2 plus x minus 2 times 4x all over x minus 2. What we do next is we look for possible cancellations. Here, using distributive property, we have x times x is x squared x times negative 2, negative 2x. Here, we look for possible cancellation. So x minus 2 in the numerator and denominator can be cancelled out. So we have 8 is equal to x minus 2 plus x minus 2 here will also be cancelled. What will be left will be 4x. So we have x squared minus 2x plus 8 is equal to, combine like terms on the right side of the equation, so we have 5x minus 2. Now we apply addition property of equality. In order to make the right side of the equation 0, so we add negative 5x and positive 2 on both sides of the equation. The right side of the equation now becomes 0. And for the left side, we have x squared. Combine like terms, negative 2x and negative 5x is equal to negative 7x. 8 plus 2 is equal to 10. So we have now transformed the rational algebraic equation into a quadratic equation written in standard form. That is, x squared minus 7x plus 10 is equal to 0. We can now solve it using the method of our choice. X squared minus 7x plus 10 is equal to 0. So let's say we chose factoring. So we're going to have x. So what are the factors of positive 10? That will give us negative 7 when added or subtracted. That would be negative 5 and negative 2. Apply zero product property. We have negative x minus 5 is equal to 0 and x minus 2 is equal to 0. Solve for x. X sub 1 is equal to positive 5. X sub 2 is equal to positive 2. Therefore, the solutions of the given equation are 5 and 2. So that is how we solve quadratic equations that are not written in standard form and rational algebraic equations transformable into quadratic equations. Thank you very much.